Hey everyone, my name is Ajay, and in part 04, we are going to talk about Azure VPN gateways. Let's get started with a connectivity introduction. On my slide, you can see I have a VNet 1 in one region. VNet 2 can be in a different region or in the same region. And I have some data center or maybe some remote offices at multiple locations. My data center remote offices can connect to Azure on either express route or public internet. So we are going to discuss about the public internet infrastructure. So I can establish a tunnel from my remote offices to Azure, and all these tunnel will be terminated on the gateway what we created here, which is a part of the VNet 1. Maximum I can create only one gateway per VNet. Similarly, I have another site which we want to connect to the same VNet. So I can establish another tunnel to the same gateway. And this is something based on the public internet infrastructure. Now, either I can terminate or access VNet 2 via the second gateway, which is here. I need to provision a separate tunnel. Or I can use VNet 1 as a hub location. So all my traffic from one data center, it can come to VNet 1, and VNet 1 can be transit, and from here I can access my VNet 2. Between VNet to VNet connectivity can be also established based on these VPN gateways. Earlier we talked about VNet to VNet connectivity, which is very simple. You don't need to do much, but this is something which is based on your gateway to gateway connectivity. Though you are going to have the public infrastructure, the public IP basically, but while connecting this gateway to gateway, you are going to use the Microsoft infrastructure. Let's try to understand what is a VPN gateway. So a VPN gateway is a specific type of virtual network gateway that is used to send encrypted traffic between an Azure virtual network and your on-premises location over the public internet. Each virtual network can only have one VPN gateway. All VPN tunnels share the available gateway bandwidth. A virtual network gateway is composed of two or more VMs that are deployed to a specific subnet that you create and call the gateway subnets. So you can see whenever you provision the gateway, it is automatically going to provision two of the VMs. So one thing we need to understand, whenever we provision any of the resources in Azure, they are going to be some sort of the VM, and you are going to run some sort of the specific application on top of that. These gateway subnets can have the routing table. Since these are deployed automatically, you're not going to have any sort of admin activity which can be performed by you. It is all automated. There are two types of VPN gateways are available. So one is which we call the VPN, another one is express route. Your first VPN type is going to consume your public infrastructure, and the second type is your dedicated lines to your nearest Azure location, which is called the express route. Further, your VPN can be based on route or policy. So what are the components we need when we build the basic IPsec connectivity? So you can compare, this is my router 1 or maybe the firewall 1. This is my router 2 or firewall 2. I'm going to have a public IP address, which we call PIP on the external interface. This is my LAN side, this is my LAN side. So from LAN to LAN, this is going to be my encryption domain. And all the traffic is going to be encrypted, hence we call this connectivity as a VPN. Same concept is going to be applicable here. You can replace this router with the gateway, And so gateway, whenever you provision the VPN gateway, it is also going to have a public IP address, which you need to provision. So both sides are going to have the public IP address. Let's talk about a design which is going to be site to site. For this example, I have a DCO, the remote offices, where I might have some sort of the router or the firewall and want to establish a connectivity to Azure. So I have a VNet 1. In this VNet 1, I already provision the gateway connectivity. So whenever I provision the gateway, VPN gateway, it is going to install two of the VMs. One VM is in active mode, another VM can be in standby. However, you have an option, you can choose both the VMs in active. So when I provision a VPN connectivity, I'm going to terminate my connection on the active VM. In case of any failure, this connection will be shifted to the standby VM. And the switchover time is going to be somewhere around 10 to 15 seconds. This is the active gateway deployment, and you can see I have two tunnels. One is from DC location to the active one, and my another tunnel goes to another active VM, which is part of the VNet one. Active deployment with multi-site. I have my first branch here, my second DC or remote office is here, and my gateway is deployed in active mode. Hence, I'm going to have total 4 tunnels. Each location will have 2 tunnels. One is for this active, another tunnel goes to this active. Similarly, from here, the first tunnel goes to this active, and the second tunnel goes to this active. So total number of tunnel, I'm going to have 4. Same concept is also applicable when you talk VNet to VNet over the VPN gateway. So if I have chosen active deployment, both the sides for the gateway, then again I'm going to have the total number of tunnel, which is going to be the 4. While we deploy the gateway SKUs, these SKUs are going to be the VMs. We need to consider these VMs very carefully based on our requirement. So for example, if I go for generation 1 basic SKU, then maximum tunnels, which is going to be site to site, I can configure only 10. Point to site, SSTP connections can be max 128. Point to site, IQV2 OpenVPN connection not supported. And aggregated throughput benchmark is going to be 100 Mbps. This 100 Mbps is going to be shared across all the tunnels. BGP is also not supported here, and there is no zone redundant provisioning can happen. Hence, we need to be very clear what is our requirement. Based on that, you can go for generation 1, there's a generation 2 also, and there are many. So you can go to Azure portal and look at the specification of these SKUs. You can also see there's a generation 1 and BGP is supported, and you can see it is saying this is a zone redundant. So zone redundant deployment, basically it is applicable to express route. So from express route circuit, to avoid any sort of outage, you can deploy these VMs, the 2 VMs, either in a same zone, or they can have one in one zone, second one goes to another zone. Let's talk about the pricing. So gateway is going to have a provisioning of 2 VMs. So there are going to be charges for your compute and charges for the bandwidth. How much data is being transferred. So there's some pricing for that bandwidth as well. Cost for active setup is same as active passive. A gateway type cannot be changed from policy based to route based. So you need to delete and reprovision it. There is only authentication which is possible is going to be the pre-shared key as of now. And also there's a small limitation while you choose your subnet. Minimum you can go for /29 for provisioning. However, you can choose higher. That is choice up to you. Let's recap what we have provisioned so far. So my VNet to VNet 2 connectivity, which is based on the regional VNet peering. My VNet 1 to VNet 3 is something which is based on global peering. Let's verify where our resources are provisioned. So this is my VNet 1. This is provisioned in Central India. My VNet 3 is provisioned in UK West. My application subnet is going to be for VNet 3 1044.0/24, and the VNet gateway subnet I'm going to provision 1042.0/24. This is the current status which we can see for our global and regional peering. My VNet 1 to VNet 2 it is connected. My VNet 1 to VNet 3 it is also connected. Let's verify the testing which I want to perform from app Unix machine 1, which is part of the VNet 1, to a machine which is part of the VNet 3. So from VNet 1, I can ping a machine which is 1044.4, which is part of VNet 3, and I see I'm getting a response. Since we are going to configure VPN peering, so I remove the VNet 2, and I'm going to provision a connectivity from VNet 1 to VNet 3, which is going to be based on your VPN peering. Let's do some cleanup for the peering which we already created. Those were VNet 1 to VNet 3 and VNet 1 to VNet 2. You can click and delete this peering. So I already deleted it. Hence, you cannot see anything here. So all the connectivity from VNet 1 to VNet 2 and VNet 3 that is broken. Now our first task to provision the gateways. So you need to choose the virtual network gateways. Click on create. Once you hit the create button, you are going to look at these fields. Subscription, it comes by default. Resource group, it comes by default. I have given a name VNet GW. This means it's a gateway which belongs to VNet 1. My region is going to be Central India. I need to choose a gateway type. In this case, it is going to be VPN since we don't have any private circuit to configure the access route. VPN type is going to be route based or policy based. In this case, I'm going to choose the route based. SQ type. You need to choose the SQ type. If you hit on the drop down, you're going to see so many options. As of now, I have chosen VPN Gateway 2, which is going to be the generation 2. Which virtual network this gateway belongs to, that is something you need to specify. So in our case, this gateway belongs to VNet 1, and then I need to define the range. So this range was already reserved. So you don't need to create the subnet initially, but while provisioning the gateway, you need to define the subnet. So my subnet 10.10.2.0/24. However, I have a choice. I can go for /29 as well. Now we need to decide what is going to be the public IP address. You might have existing one. If you want to use it, you can also use it. In my case, I don't have any public IP already provisioned, so I need to create a new one. So I have given a name VNet1 PIP. That means this PIP belongs to VNet1. Now we need to decide what is going to be our mode. As we discuss, you can provision in active passive or active active. So I'm going to provision in active passive mode. So this I will leave to the default, which is disabled. I'm not going to use BGP as of now, so this option is by default and disabled. Now I need to hit the review and create button. Once you hit the review and create button, there is going to be a process of the validation, which checks all the fields what you have mentioned, whether they are correct or anything which is missing. Once this validation is passed, you need to hit on the create. While you hit on the create, your deployment in progress, those are the notification which you can see. So these deployments, the first gateway deployment for VNet when I created 16 minutes ago, then I already provisioned another gateway which is part of the VNet 3 10 minutes ago. In total, it can take maybe more than 30 minutes. And then you are going to get the notification that both the deployments, they are already succeeded. This is the current topology, network topology, what we see. So I have a app Unix machine 1, which is part of the VNet 1, and that is part of the subnet application. Similarly, I have same machine here, app Unix 3, which is part of the VNet 3, and that is also part of the subnet application. Now, two things got added here, VNet Gateway and the Gateway Subnet. So this is the VNet Gateway what we provision for VNet 1, and this is the gateway what we provision for VNet 3. Let's verify how many gateways we created. So if I go under the virtual network gateways, I can see there are two gateways we provision. The first gateway VNet 1 GW and the second gateway VNet 3 GW. My first gateway it is part of the Central India and my second gateway it is part of the UK West. Now we are going to provision or configure the peering basically for the gateway what we created. So I am under VNet 1 gateway, and if I go to the connections, I see nothing is provisioned as part of the peering. So I need to hit add button to the connection provisioning. The moment I hit the add button, you need to mention the name of the connection. This connection is going to be VNet 1 to VNet 3. There are connection types. Drop down, you can see what we want to create. So VNet to VNet, we already provisioned in our previous video. And I'm also going to do the same activity here, but this time this VNet to VNet is going to be based on the gateway. So I have chosen VNet to VNet. You have other options also, site to site, express route. The second option comes choose virtual network gateway. Since I'm part of the VNet 1, I need to define the gateway which is going to be the remote. In this case, it is VNet 3 gateway. Now, I need to define some pre-shared key. In this case, I have defined VPN 123. You also have option to choose whether you want to go for phase 1, which is based on the IKE version 1 or IKE version 2. I have chosen IKE v2 and then you click on OK. So far, we configured one side of gateway, which is VNet 1 GW. And we can see even after giving the pre-shared key, connection is coming not connected. If you remember, when we were provisioning VNet to VNet connectivity, we were just configuring one side of the connection and another side of connection was auto provision. But when the connectivity or the peering is based on the VPN, you need to perform the same step on both the sides. So whatever the pre-shared keyword we have defined, you need to configure the pre-shared key while you provision your VNet 3 to VNet 1 peering settings. I've already done that. So now we can see my connection is connected and it is VNet 1 to VNet 3. Now let's perform some bitrate testing and see how it looks when it comes to the performance. So on machine app Unix 1, which is part of the VNet 1, I'm running iPerf in a server mode. And this is the testing on the client side, and this machine is part of VNet 3, which is app Unix 3. And our results are here. The bitrate is 21.4 megabytes per second. And if I recall it, it is almost same. So we do not see any major performance issue here. Performance almost same. Thanks for watching. I will see you in the next video.